Hello, this is Ian Woolf, producer of Diffusion Science Radio. This show depends on your support. Please make a donation directly with the PayPal button at www.diffusionradio.com or support Diffusion by downloading a free audiobook from audibletrial.com/science or go to diffusionradio.com/support and click on an Amazon link or buy my nano drones.
Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we inject weird and wonderful science directly into your brain. I'm Ian Woolf. On this edition, we have real space cowboys and machine learning. But first up, here's the news. Alien world in the Goldilocks zone. Astronomers have discovered a rocky Earth-like world orbiting a star just 14 light years away from us, orbiting in the Goldilocks zone around its star where liquid water can exist. The star is Wolf 1061 in the constellation Ophiuchus, the snake bearer, just 130 trillion kilometres away from the Earth, or the distance light travels in 14 years. The University of New South Wales team, led by Duncan Wright, found 3 planets are orbiting Wolf 1061, a red dwarf M-type star. All 3 planets have the right mass and size to be rocky like Mercury, Venus, Earth and Mars, instead of huge and gassy like Jupiter and Saturn. The innermost planet is too hot for liquid water. The third planet is too cold for liquid water. The middle planet, Wolf 1061c, is just right for life, if the water is actually there. The planet Wolf 1061c orbits the star every 18 days, 10 times closer than the Earth does to the Sun. However, the star Wolf 1061 is a red dwarf, so it's much cooler than the Sun. Since the planet Wolf 1061c orbits so close to its star, there's a good chance it's tidally locked, like the Moon towards the Earth, with one side of the planet always facing its star, while the other side is always in darkness. This would mean one side was hot while the other was cold, and any atmosphere would carry strong winds. The planet Wolf 1061c has a mass over 4 times that of the Earth. The team discovered the planets by looking for a wobble. The gravity of planets orbiting stars caused the more massive star to wobble around the centre of their orbit. Astronomers can detect this wobble by looking for the red and blue shift of the light from the star as it moves. This colour shift of red away from us and blue towards us is called the Doppler effect. Light radiated from objects moving away have their waves stretch longer, which makes them redder. Light radiated from objects moving towards us have their waves compressed shorter, which makes them bluer. Sort of like how the sound of a car coming towards you, passing and then away from you, sounds like high and then low. These colourful wobbles tell astronomers the number of objects, their distance from the star, as well as their estimated mass and orbit. If the planets transit in front of Wolf 1061, then we'll see light coming through their atmospheres as they cast a shadow. This light through the atmosphere will tell us whether or not the planets have any water, or any interesting carbon-based compounds that might indicate life. The University of New South Wales team made the discovery using archived observations of Wolf 1061 collected by the High Accuracy Radial Velocity Planet Searcher, HARPS spectrograph, on the European Southern Observatory's 3.6 metre telescope in La Silla in Chile. They applied new ways of looking at the old data taken over 10 years and discovered new worlds. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Did you ever want to be an astronaut? Are you excited about space? Then Space Camp is an experience to aim for. Ed Buckbee is a former NASA public affairs official and founder of Space Camp. Ed gave a talk at Sydney Observatory about the real space cowboys and his time with the Mercury, Gemini and Apollo space programs and astronauts. I spoke to him the next day at his hotel just before he boarded a celebrity cruise ship to give more talks. I began by asking him, who are the real space cowboys?
Well, that's a group of astronauts that I work with in the NASA days that have now retired, and we basically formed a relationship, and we go around the country, actually around the world, speaking about space. I introduce them and basically describe and show the visuals, and they fill in their personal experience. So it's an opportunity for people who remember the moon landings and saw them to actually meet face-to-face with the real guys that walked on the moon's surface. So that's what we do, and we support Space Camp, of course, and other things, other educational programs that are available to young people. And what we're trying to do with that effort is to keep the dream of space flight alive worldwide, and remind people that is the most exciting frontier that we can explore in our time, is to go into space and experience space for peaceful purposes, explore it, and understand it, and someday actually see people flying in space almost like you would fly on an airplane trip across the country, across the world. So it's an opportunity for us to market basically what we've done and keep people dreaming and thinking about the future.
And the innovations from the space program touch every part of modern society.
This is true. The spin-off, we called it, from the technology that was developed is really something that we take for granted. You walk around with cell phones and all sorts of electronic devices that were made possible because we had to figure out how to communicate with astronauts 240,000 miles away, keep their body temperature, their pulse rate, and all of those vital signs available to us so that we would know that they were safe. So NASA had to develop technology to make that happen, and consequently in our system we were allowed to take that technology to other companies, and those companies developed their own products. The chip, I think that was the secret to it all. And we talk a lot about, micro-miniaturization, but the chip being reduced to such a small thing that you have it now probably on your credit card. And it came out of the technology. NASA didn't develop the chip, but the technology that NASA needed to go to the moon enabled companies to develop those kinds of things. And that's really what enabled us today to be so able to communicate worldwide and have information available to us at our fingertips because of that technology. It was developed in the early days by NASA.
So space is like a focus. Solving the problems of space lets you develop things that let you solve problems you never even knew you had.
I think that's true, and it's very difficult at times to convince the public that the value that we get from the investment will be brought back, because we didn't spend the $20 billion on the moon. We spent the $20 billion on Earth with the companies and the personnel. So it is difficult to communicate that, but what you find is people realize when they go to a doctor, when they fly on an airplane, when they drive a car, that technology that enables those vehicles to perform perfectly and the doctor to analyze your problem and detect what it is, a lot of that came out of the development of technology to go to send our astronauts to the moon. So again, I think we have to continue to explore space, because that will enable us to advance our technology, improve the way we communicate, and consequently that'll come right back to us in our everyday way of life.
And going back to the beginning of the space program, what sort of men did it take to risk their lives to be the first astronauts?
it really took the fighter pilots and the what we call the jet jockeys and the fighter pilots. And the reason for that is they were trained to deal with emergencies. And in early days of the space program, we were actually taking the warhead off the missile and putting an astronaut on the missile. And it was not a highly developed, safe way to travel by any means. So consequently, we had to have guys that were comfortable, getting in the cockpit, knowing that this thing could fail, and how do I get off this machine in case it fails and whatever. So, and they were the kind of guys that wanted to be challenged. And they understood machinery. They understood mechanical devices, and they knew that they could fly it if they had to. And so that's how we started off the space program with fighter pilots and test pilots that were trained to do that, and they fit right well into the astronaut corps. Later, we of course changed and took on doctors and other scientists, and today there are many of them flying that come from that era. But the early days, it was a fighter pilot, jet jockey era, and that was the original Mercury astronauts that I worked with a long time. They were all fighter pilots, and they all understood that this was a dangerous business, and they were volunteering to fly there.
And for the astronauts of tomorrow, there's space camp.
Yes, that's what I really enjoy, is being able to share with young people the opportunity that they too could become an astronaut. And then I try to explain to them that you don't need to get excited about the moon. You need to get excited about going to Mars, because that's really what your era will experience, the opportunity to land on Mars and to place the flag of your country on the planet Mars. So I think space camp is an opportunity for young people to get a glimpse of their future, to understand what they could become. They might want to be a flight director. They may want to be an engineer and work on the space machine. They all may not want to be astronauts, but the opportunity that space camp offers young people is to give them some options that they can think about, and especially understand that science and math is very important in their training and their education process, because if they want to become involved in technology, they need to have a good basic understanding of science and math. So that's what space camp's all about. We're training the future astronauts at space camp, and we're training the future engineers and scientists at space camp.
And people come from all over the world to space camp.
And they certainly do. They come. We have, for example, this past year, 600 children came from Australia to space camp, and we see that growing in the future. And hopefully, space camp will have a presence here in Australia in the future, because I think this country, this part of the world, is an ideal place to learn and understand about space and get excited about the space program. And that's what I hear and see from teachers and students that have come to space camp from this country. I sense that they want to have a partnership in space. They want to understand what's it like, and they would like to have a relationship with NASA and the space camp program. And that's what I hope I can help happen in the future, is to develop a partnership between the NASA facilities and space camp here in Australia.
And what are the ages of people that go to space camp?
Well, it starts off at a parent and child can come at the age of 7, the child can, but when we start talking about the children themselves, we start off at 9, and then you have 9, 10, 11, and then 12, 13, 14. So it goes right on up the age bracket all the way to adults. So there's various stages that you can come to: Space Camp, Space Academy 2, Aviation Challenge, the aviator program. All of those are offered, and they're available on the website. And there's people here in Australia who offer that program, and you can check that out as well on the website. But it's a great opportunity for kids to get motivated about their future, to kind of touch space and to get a glimpse of what it might be if they were become involved in space travel.
And so, what's an experience like for someone who goes to space camp?
Well, it's a 5-day experience, and what you do, you learn about rocketry, you learn about astronaut training, you also participate in a mission, and the missions are varied. Some of them may be space shuttle missions, others might be flights to the moon, and some will be flights to Mars. So It's a very hands-on type experience. And we promote teamwork, self-confidence, leadership, decision-making, all those things that a young person will appreciate learning about. And it's a lot more, and it's not like being in a classroom where they just sit and listen or read. This is a hands-on experience. And you're assigned a responsibility, like you might be the flight director on this mission, the next one you might be the shuttle pilot, and you have an important part to play, and you are a member of the team, and you must do your part for the team to be successful. And the kids love competition, as you well know. And we have a Right Stuff Award, we have a Top Camper Award, all those kinds of things are issued at the end of the week. And it's team against team, and lots of good competition. Young people love that. So it's a place where you can really touch space, and it goes on for a week, and it's very much a hands-on experience that young people love, and it's located in Huntsville, Alabama, and hopefully we'll see one of those facilities here in Australia in the future.
And if people want to find Space Camp online, where should they look?
Spacecamp.com will be it, and that'll bring you up to date with everything you need.
And I know you haven't been very long in Australia, but do you have any opinions on the benefits we might get from having our own space agency since we don't have one?
You know, that's something that's kind of surprising that Australia has not been involved that much. You know, in the early days, the tracking stations in Australia literally helped the Mercury program become successful. I recall the time that Neil Armstrong came down the ladder and this very old black and white scene, that signal was actually tracked by Australia and sent back to the world. And it was enabled everybody to see the real guy coming down the ladder, stepping on the moon. Even though it was a fuzzy black and white picture, I'll always remember that. And I don't think many people realize that signal was enabled by the tracking station here in Australia. So it's a program that it represents the future. You know, it's a frontier that we're just beginning to explore. And it seems to me that it would be such a natural for the Australians to be a part of the space program. Maybe flying experiments on the International Space Station, or quite possibly participating with the commercial companies like Virgin Galactic and others that are now developing their own vehicles. I would love to see Australia participate with some of those companies, flying satellites, or basically flying experiments there, and eventually it'd be great to see Australians be able to fly in space from a vehicle like that.
And to the people that say that space is too dangerous to be explored, or it shouldn't be explored except by robots, what's your answer to that?
You know, a robot can only do so much, and until you put the human in the cockpit that has the ability to make decisions at the last moment, nobody's going to get excited, in my view, about sending a robot to Mars. To send a guy or a gal to Mars, it's a whole different ball game. The world will be totally committed to watching the first human land and walk on the surface of Mars. 35 million miles away. It's going to take 7 months or so to get there. They'll probably stay 3 years. It's going to be a major effort, and I won't have a chance to see it, but you and others will have that opportunity. And it'd be great to see Australians involved in that program in whatever way they wish to go. But again, I think flying back and forth to Earth orbit is something that's very easy to accomplish, and we're going to see more and more of that with the private companies.
And on the subject of pilots making decisions that robots wouldn't be able to make, wasn't it the case that Neil Armstrong needed to make important decisions for the moon landing that an automated landing would have messed up?
Exactly. And it's a very good example because Neil was told that a particular landing site was where he should bring his spacecraft down. He came down there and looked at it, and it turned out to be a totally unprepared. It had huge boulders. It was unsafe. So at the last moment, he put that machine in a hover position and moved over about 100 yards and brought it down in a safe landing site with only 17 seconds of gas left in the tank, by the way. But that was done by Neil himself. The computer basically was saying, no, you should land here, and that would have been a disaster. We probably would have had our first crew stranded on the moon's surface if he had landed there. So that's why you have to have a guy or a gal in the cockpit. if you're going to go somewhere and land. And I think that's a very perfect, good example. Robots are great as what I call the test people to go first. Let them go with robots and land and discover as much as they can. But the public, the people in the world are never impressed with just sending a robot. They want to see a human walk on Mars, and that's what I hope will happen in the future. And it could be in 2030, 2035, that the U.S. and its partners, and it depends on who they might be, could be many different companies or countries. I think you're going to see a human walk on Mars in that time frame. Well, that's my first visit to Australia, and I am very impressed with the country. Sydney is a wonderful city. You really have a marvelous place here, and the people are very generous. You feel excitement in Australia. You feel much more conscious of the environment. It's clean, it's beautiful, and it's safe. That's one of the things that, unfortunately, in our world today, that a lot of people worry about when they travel, is the safety factor. And everyone feels comfortable here, and I think that's another part of your offering, is you have a wonderful community. And they welcome many, many international visitors. I see many people from other countries here. So I'm looking forward to climbing on board the Celebrity cruise ship in about 2 hours and going down to Melbourne and see the rest of your country. And then we'll whip up to New Zealand and end up in Auckland. And so I'm going to have about 3 weeks of enjoyment in this part of the world. It's a great, great part of the world to visit. It's my first visit, and I'm very proud to be here. Thank you very much for your hospitality.
Ed Buckbee, thank you very much.
That was Ed Buckbee, founder of Space Camp. You can find stories about his experiences with the first astronauts in his book, Real Space Cowboys. A special thank you to Jackie Slavero from One Giant Leap for helping organise the interview. The latest telescopes are generating so much data that observatories can't afford to keep it all. How do you effectively use such huge amounts of data in a reasonable time? Elise Hampton is from the Research School of Astronomy and Astrophysics at the Australian National University in Canberra. I met her at the Astronomical Data Analysis Software and Systems Conference. I began by asking her about her machine learning project.
Okay, so my research has been into using machine learning to help us solve a problem that we couldn't previously solve. So we're studying galaxies in more detail than we have before, but that means we have a lot more data than we're used to dealing with. So we take spectrums of galaxies to tell us about the stellar content, star formation, the black holes, shocks and winds, and we have to process that data by fitting models to it. Now the problem with the models is that they are complicated and we have trouble working out which model is best. So my project has actually been to use a neural net to make the decisions of the models that will best fit our data.
For the listeners, a neural network is a simulation of the way that nerve cells talk to each other in the brain to make a decision.
Yeah, so it's pretty much trying to follow how our brains work by using sort of nodes, which are kind of like our neurons, and they talk to each other and do different processes depending on what part of the neural net, just like our brains use different parts.
And so do you have to train the neural networks instead of programming them?
Yeah, so the idea behind a neural net is that you don't explicitly program it to do what you want. You teach it how to get to the right answer. So we have a training set, which is all made by astronomers, and we give it to the machine with the answers. So it goes through and tries to work out if it can get the right answer, and then it keeps reiterating over the data set until it's really close to what the answer we gave it to. And then we know it's learnt what we've told it to do.
It's looking at the models and it's trying to get them to match the observations, is that right?
Yeah, so we have our observations and we fit 3 different types of models to them, and then we just want to know which one is best to describe our data.
And so this is something that would be really laborious to do personally?
Yes, so in the beginning we decided to do this using just people, and it turns out to do this decisions for our galaxies, it takes an hour to do this per one galaxy. So we're dealing with surveys that are on the order of 3,000 galaxies now. So that's 3 years gone just making decisions, and it's not worth it. So with that in mind, we've built a machine that can do it in 8 minutes. So we're no longer worried about not having a job at the end of it, but now we can do science a lot sooner.
What sort of models, what sort of things are you finding out using this tool?
So the models we're fitting are Gaussian, so we get peaks in our spectrums to show that different elements are present. So the Gaussians we fit 1, 2, or 3, and this helps us identify where there are multiple processes happening in our galaxy. So if we have 2 Gaussians that need to be fit, that means there's probably 2 different processes happening in that galaxy. And now that's interesting because then we can start looking at how the different processes are interacting with each other and what it means for the galaxy in the future.
What sort of processes are happening in these galaxies?
So in these galaxies, we're finding star formation. We're also finding accretion around black holes. We find winds, so winds that are the same size as the galaxy just passing through it. We find shocks through it as well, like inflows of material, outflows of material. It's all very exciting stuff.
So galaxies are really active places on the big scale.
They are very active in the end, yes. So with the machine learning, we're able to get to the point of analyzing the data a lot faster, which means we're going to be able to sooner start understanding more about galaxies.
Well, Elise Hampton, thank you very much.
Thank you.
That was Elise Hampton, helping astronomers use the giant amounts of data they're amassing from modern telescopes using machine learning. And that's all from us this week on Diffusion. Would you like to join us? We need more people contributing stories to Diffusion. You can send your contributions, opinions, congratulations and helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. And please do send me email so I know you're listening and you'd like to hear more episodes. Please like the Diffusion Science Radio page on Facebook and rate us on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. Checking production was Charles Willock. I produce Diffusion, which is broadcast around Australia on the Community Radio Network, including 2HHH in Hornsby, Ku-ring-gai, 2NVR in Nambucca Valley, 2XX in Canberra, and 3MBR in the Mallee Border districts of Victoria and South Australia. Diffusion is syndicated globally on the National Science Foundation's Science 360 internet radio station and also on astronomy.fm. Subscribe to our podcast on the Diffusion website, www.diffusionradio.com. That's www.diffusionradio.com, and check the website for links, photos and videos about this week's show. And if you enjoyed the show, then you can explore the more than 700 previous episodes archived on diffusionradio.com, where the shows are labelled by keywords so you can focus in on the stories you want to hear. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.